Welcome back to Water Quality in the Pacific Northwest. We're covering a series of lectures that deal with surface water quality. We're continuing to talk about pollutants and measurements. So far, with surface water quality, we have covered a lecture on nutrients, a lecture on sediments, a lecture on erosion. Last lecture, we introduced the process of eutrophication, and today, in Part E, we're going to continue with our discussion on eutrophication. So eutrophication is a process whereby a water body becomes nutrient rich with age. I wanted to continue to talk about some examples of eutrophication. At the end of the last lecture, we talked about Lake Erie and we talked about the Chesapeake Bay. Today I'm going to pull that a little bit closer to the Pacific Northwest, and let's take a look at southern Idaho and northern Idaho. In the southern part of the state, we're starting to see portions of the Snake River in the late summer develop algal blooms. And we're talking about lakes in southern Idaho, and we're talking about reservoirs, the water behind reservoirs where the water is stagnant. Now, we're seeing these algae blooms because we're introducing sediments into the stagnant water. And these nutrients can come from sediment. Sediment rolls off the land. Phosphorus particles are often attached to the sediment, and thus they serve as a source of nutrients for the algae to grow. Or they can come directly from nutrient runoff, such as fertilizers from farmlands, such as nutrients, nitrogen and phosphorus from animal feeding operations, from wastewater treatment plants, nutrients, and also other things, urban use. In the northern part of the state, one of the examples that I think that's worth talking about with eutrophication is our three northern large lakes. And one of these three northern lakes is Lake Coeur d'Alene. Most people see Lake Coeur d'Alene as a pristine, beautiful lake, and it is a very beautiful lake. However, the Lake Coeur d'Alene watershed keeps growing with more and more and more people. Today, such that there are about 150,000 people that actually live within the Lake Coeur d'Alene watershed. More people, more activity, more nutrients, more sediments. That's kind of the situation with northern Idaho. So with Lake Coeur d'Alene, we're starting to see problems starting to occur. There's a view of the edge or the shore along Lake Coeur d'Alene, and that's an osprey nest that's on a telephone pole in the lake. We're starting to see enrichment of nutrients and sediments in this lake because of human activities. The enrichment can come from many things. If we look at the shore of Lake Coeur d'Alene, we see forest lands, we see croplands. Any soils that are left bare, where we don't have vegetative cover, when it rains, those sediments can wash down. So we can get sediments from croplands. We can get nutrients coming off of croplands. We practice forestry on the forest lands by the shore. So if we don't harvest our trees correctly and we leave bare ground with rainfall, some of those sediments can wash off the forest land into the lake. We also have a significant amount of development along the lake shore. You take a boat ride around the lake and you see all kinds of homes going up or in various stages of construction. For instance, here's a home along the shore. That home individually doesn't do much harm to the lake, but when you take hundreds and hundreds and hundreds of homes and you consider the runoff that can be coming from these homes, that's a significant threat to the lake. In addition to that, people recreate on Lake Coeur d'Alene. In the middle of the summer, the boat traffic on the lake is amazing. Within these boats, people have things to drink, they have waste. Anything that is discharged from this boat that would leak nutrients into the lake can be a potential source of nutrient enrichment. we go back to the shore for a few moments. Here's a string of homes along the shore of Lake Coeur d'Alene. These homes are not in a city, so they're not connected to a sewer system. Consequently, each one of these homes has its own septic system, which consists of a septic tank and a drainage field. If the septic system, particularly the tanks, are in good working order and maintained, they pose very little threat to nutrient enrichment of the lake. However, if these septic tanks are not maintained, which means they need to be pumped out every 2 to 3 to 4 years, if they aren't maintained, the septic tanks can fill up, nutrients can leak out, and those nutrients may eventually end up in the lake. In addition to these single homes, we have several communities. They're small communities, except for Coeur d'Alene, that are around the shore of the lake. This happens to be the community of Harrison on the eastern part of the lake. Not many people live in Harrison, but there are quite a few homes here, and most homes have lawns, most homes have gardens. When you talk about lawns and gardens, you're talking about the potential for nutrients not staying on the land and washing into the lake. So gardens along the shore, things like that. So collectively, we've got a beautiful lake here, but are we loving it to death? Are the amount of human activities going on here starting to cause nutrient enrichment and also sediment introduction in the lake, which eventually could lead to eutrophication? So we've introduced this topic of eutrophication in the last lecture and a half, and today we need to continue with this discussion and talk about controlling eutrophication. How do you control eutrophication? Well, first, you identify the causes of the eutrophication. Where are the nutrients coming from that cause the lake to be eutrophied? Where are the sediments coming from that cause the lake to be eutrophied? And then you need to develop a control strategy to limit nutrients and sediments coming off of each of those potential sources. There are 3 big groups of sources that put nutrients and sediments into lakes, and I'd like to briefly talk about them today. Erosion from croplands. If you don't keep the soil in the field, those sediments from the soil will run off the field and enter the lake. And remember, sediments make the water turbid, which can lead to a decline in benthic plants. And sediments also have phosphorus attached to them, which can cause phytoplankton to grow. In addition to that, to produce good crops, we apply fertilizers to these soils. Any fertilizers that don't stay on the land may run off with rainfall, or they may leach into shallow groundwater and then into the lake directly, into the lake body of water directly. So that's another source of potential eutrophication. And agriculture consists of an animal industry. Any runoff of animal waste from feedlots, from dairy barns, contains organic nutrients, which are also nitrogen and phosphorus. So any of that runoff can enter into the lake. So we've got different sources in agriculture that can contribute nutrients and or sediments to a lake and can cause eutrophication to occur. In addition to the agricultural sector, the urban sector also contributes nutrients and sediments to water bodies. If you look in an urban area, most people have lots that are much larger than just their homes, and they have lawns and they have gardens. Well, if the lawns and the gardens cover virtually all of the soil, we don't have erosion and we don't have sediments washing off the land. However, if those lawns are not in good shape and those gardens have bare soil, a rainfall event or an over-irrigation event may lead to some of that sediment washing off the land and into the lakes. In addition, homeowners pride themselves in having nice lawns, having good gardens, good ornamental shrubbery, and to keep these lawns, gardens, and ornamental shrubbery in good shape, they often apply fertilizers. Well, if the fertilizers stay on the land, we're okay. However, if the nutrients from those fertilizers, namely nitrogen and phosphorus, wash off the land, they can enter the lake and they cause problems. When I talked about agriculture a few minutes ago, we talked about the large animal industry. Well, in an urban area, we don't have a large animal industry, but lots of people have pets. People that have pets that defecate on their lawns or in their gardens, if they don't pick up this waste and throw it away, you get a rainfall event or you irrigate that property, those nutrients become solubilized and they can run off with the storm water or in other ways, and those nutrients can reach the water body. So we've got agriculture, we've got urban sectors. And the third sector that's a major cause of eutrophication are sewage effluents from animal and human waste. Most communities have wastewater treatment plants to clean up the water that comes out of our homes as waste. Wastewater treatment plants are very effective in removing organic materials from our waste stream. However, a lot of communities don't have modern, up-to-date sewage wastewater treatment plants. For instance, well over 60% of our wastewater treatment plants in the Pacific Northwest aren't capable of removing phosphorus from the wastewater stream. People put a lot of phosphates in the wastewater stream because our laundry detergents contain phosphates. The phosphates do a really good job in helping cleaning clothes. But since our wastewater treatment plants, or a majority of our wastewater treatment plants, do not remove phosphorus right now, that phosphorus goes directly back into the water stream. And if that water stream includes a lake or a slow-flowing body of water, we can see eutrophication occur. Also in sewage, when we talk about people that live in rural areas, remember they're not connected to sewer systems, but they have their own simple individual wastewater treatment plant. And those wastewater treatment plants have to be maintained. The septic tank has to be pumped out when it fills up, or those nutrients can leak into the environment. So we have several different sources where nutrients and sediments can wash off the land and end up in lakes. We generally see eutrophication as a bigger problem where populations are larger, or where these three activities, agriculture, urban populations, and sewage treatment, are on a dense basis. So the more people in the watershed, the more difficult it is to keep sediments and nutrients out of lakes. Well, if you take a look at those three areas, agriculture, urbanization, and also sewage effluents, it's pretty obvious what we need to do. Just simply keep these nutrients and sediments that are associated with these industries out of the water. What we try and do from a technical basis is we try and use what are called best management practices, generally abbreviated to the acronym BMPs, a best management practice. A best management practice is a practice that does two things. One, it's used to protect the environment. And in this case, when we talk about eutrophication, it's used to prevent nutrients and sediments leaving the land and entering a water body. So we protect the environment, and a best management practice also has to be something that's economical to employ for the person using it. So we want to protect the environment, but not infringe upon economic activity, like an animal feeding operation. So some of the simple things we can do is we can use best management practices on farms, on lawns, and gardens. So we cover the agricultural sector, the urban sector. Some of the simple best management practices we can do, they're just logical. 1. On farms, lawns, and gardens, you keep the ground covered. You never have any bare soil exposed to the environment. If you keep vegetation on all the land, the chance for erosion is very low. So we use best management practices to prevent erosion. And obviously, if you keep the soils covered with vegetation, you also reduce the incidence of nutrients washing off the land. So those are two real simple BMPs. There's long lists of BMPs that you can use for different agricultural situations for both animals and plants and for lawns and gardens in urban areas. We have lots of different BMPs that we need to use. The more we use, the cleaner the water body or the lake will be in the area. In addition to BMPs on farms, lawns, and gardens, we need to make sure that sediment does not wash off the land when land is being constructed, where we're building a subdivision or where we're building a road or at mining sites. Wherever there's a chance for a large amount of bare soil, we need to have some control so that sediment and the nutrients associated with the sediment don't wash off the land into the lake. We can use things as simple as sediment traps. We might have a piece of property where we're building a subdivision and it's wet. What do we do to keep the sediment from washing off the land? We might surround that whole piece of property with hay bales. And the hay bales act as natural barriers. So as the water flowing with sediment washes into the hay bales, the sediment settles out and doesn't leave the land. We can also use things like water basins. We can build little dams and dikes around a construction site to make sure that that water does not run off the site with sediments and nutrients in it. Another best management practice we can use on land to protect it from erosion and nutrients is we can protect whatever wetlands we have. Wetlands are important because wetlands have been shown to be natural filters. Water flowing through wetlands reduces the incidence of nutrients going into water bodies. Plant roots in these wetlands suck up the nutrients. Wetlands also slow the movement of water through them, so they're natural sediment filters. As water flows through a wetland, the water slows down and the suspended sediments just naturally deposit themselves. So that's another example of a best management practice that can be used. In some areas, we have to go to a little bit more extreme. Phosphorus detergents are a main problem in areas where our wastewater treatment plants are not capable of removing phosphorus. So maybe we should be banning the use of phosphate detergents in certain areas. So remember, over 60% of our communities here in the Northwest don't take phosphates out of the wastewater stream. So communities that only treat wastewater through secondary treatment don't remove phosphorus. That phosphorus goes back into the water stream, and that water stream can end up in slow-moving water bodies, lakes, water behind reservoirs, maybe ponds, and that creates eutrophication. Now, the reason why communities don't remove phosphorus is that it's pretty expensive. Some of the larger cities in the western United States and across the country do remove phosphorus in the wastewater stream, but the cost per homeowner is fairly high. So if you're in a small community, it's usually considered not a priority. Spend your money on something more pressing than simply wastewater treatment. If you can't take phosphorus, you can't take the phosphorus out of wastewater through treatment. Some communities have gone to the extreme of banning laundry detergents that contain phosphorus. This is controversial. You'll see things on the market all the time that are detergents to clean clothes that do not contain phosphorus, and they claim they work. However, if you look at some magazines like Consumer Reports that do testing comparing laundry detergents, they will say that you really need phosphorus in the laundry detergent to produce clean clothes. So this is a pretty controversial area right now. When we talk about the wastewater stream, and we'll talk about this near the end of the course, you can install an advanced form of wastewater treatment that will remove phosphorus and or nitrogen from the wastewater stream. However, this is a pretty expensive process. Advanced wastewater treatment is required to remove nitrogen and phosphorus from wastewater. It can be done. Some communities do it right now. It's going to take us a long time to get smaller communities to do this because it's fairly expensive. So in summary, that's what we're doing with eutrophication, some of the best management practices we can use to prevent eutrophication. A lot of people would say, well, we have lots of best management practices we can use to prevent eutrophication. How come eutrophication is such a problem? Well, simply because watersheds are very complicated. And the more people in a watershed, the more difficult it is to keep both nutrients and sediments. If we have a watershed in Idaho that maybe has 3,000 people that live within the watershed, you can probably come up with enough BMPs to greatly reduce the amount of sediments and nutrients that would end up in the water bodies at the bottom of the watershed. However, if we go to something like Chesapeake Bay, the estuary in the eastern part of North America, the estuary that has declined greatly since the 1970s, it's very, very difficult to solve the eutrophication problem because you probably have 15 to 20 million people living in the Chesapeake Bay watershed, and you probably have 80 million animals that live in that watershed. How do you design effective programs to keep all those nutrients and sediments out of the watershed, out of the water at the bottom of the watershed? So it's a very difficult problem. The more people, the more difficult it is to keep eutrophication from occurring in our stagnant water bodies. Thank you for your attention. I'll talk to you next lecture. The first is the agriculture industry. Agriculture is really important because in many watersheds, agriculture is the industry that covers most of the land in the watershed. Agriculture can cause eutrophication in lakes as an industry by simple things.